Okay, so the first step is called the carbon fixation step. So CO2 comes into the plant through the stomata, and that CO2 is inorganic, but we need to form it into an organic molecule. So in the stroma, there's actually, I'm going to call it like the starting molecule. Like it's what we need to help us get started making sugars. And that molecule is called RUBP, ribulose bisphosphate. And RUBP is a great little 5 carbon molecule. And this molecule, with the help of an enzyme called Rubisco, it combines with one CO2 molecule, and it's very, very unstable. So it actually forms a 6 carbon organic molecule that's extremely unstable. So it actually breaks apart into 2 3 carbon molecules immediately. And now you might be wondering, why is there a 3 here? Because it's easier to talk about the Calvin cycle if we imagine 3 carbon dioxides coming in at the same time. Okay, but every one of these carbon dioxides is going to bind to one RUBP. So the gray circles represent a carbon. So here's 1 carbon and here's 5 carbons. And when they join together, they're going to form a very, very unstable 6 carbon molecule, which will immediately break into 2 3 carbon molecules. These are the intermediates. Okay. Now, after that, we have our reduction step. So this is where we're actually going to use our high energy molecules for the first time. So we're going to use our ATP and some of our NADPH. And each of those little 3 carbon intermediate molecules is going to get reduced into a G3P. And I know what you're thinking. You're thinking, oh, wow, we already made G3P, so we're done. The Calvin cycle's over with. Great. We already made 6 of them. Not quite. Okay. In fact, when we make 6 of them, only one of them is released. And that one G3P can be used to make glucose or other stuff. But the other 5 G3Ps are actually used to regenerate RUBP. And this step actually uses a little ATP as well. So the reason why when we take in one CO2, we only release one G3P is because even though we made 6 G3P, we need 5 of them just to regenerate the RUBP that we used in this process. So every time you want to release one G3P, you have to do this 6 times. Okay, you have to basically take in 6 of these CO2. When you take them in, you release one G3P. Every time you want to make a glucose, you have to take in 6 CO2. If you want to make a G3P, you take in 3 CO2. But every time we make 6 G3P, one G3P will leave, and the other 5 G3P will be used to regenerate the RUBP. And the reason we regenerate the RUBP is because this is a cycle, and we need to do this again. So we use that RUBP, we fix the CO2 to the RUBP, it forms a 6-carbon intermediate that breaks into 2 3-carbon molecules. We reduce those using our high energy ATP and NADPH, and then we release one of the 6 G3P, and the other 5 get reformed into RUBP. Remember, if we want to make a glucose, we need 2 G3P molecules.